Hello, this video is for the standard normal distribution, and this is part 2, the second and final part for learning intention number 52. Alright, I want to emphasize why we use the standard normal distribution. I mentioned it a bit in the last video, but I really want to emphasize it because it's important. So we like working with normal distributions. We find they pop up a lot. However, we find them hard to calculate with. So what we do is we transform the problem to make it simpler into a standard normal distribution. And then often what we do is we solve here. So we do the hard work here, we solve, but we need it to look like this again. So we transform back to the normal distribution. And the way we do these transformations is with this formula. We use z equals x minus mu on sigma to go that way. Or if you want to go back the other way, you can just do a bit of algebra to figure out how to get x. It's going to be z sigma plus mu times both sides by sigma, add mu. That's how you would get x to go that way. So that's what's happening here. To go from the normal distribution to the standard normal distribution, we use this. To go from the standard normal distribution back to the normal distribution, we use this one. Okay, so what we're going to be looking at here is the inverse standard normal distribution. Too many words to explain a pretty simple concept. You've got your standard normal distribution here, and let's say you have some z, right? You've got some z here, and you know that you want the probability, you want this area under the curve to be, say, 0.71. So you want to know, you know the probability, but you want to find this z value that means, yep, the probability of this something within this interval occurring is 0.71. What's the z value? So see, we're going backwards here. Instead of giving you the z value and saying what's the probability, this time we're saying here's the probability, what's the z value? And we're going all the way under the curve, all the way to negative infinity, all the way up to this limiting value. Way too complicated to calculate by hand. It would be ridiculous. So we use a Cas function to do this. It's called inverse normal. So we're going to be using the Cas function inverse normal. And it has a few arguments that we'll go through in a moment. So we're going to use Cas for this. Alright, let's have a look at a few examples. Here's example 1. Find the value of c in the following. So the probability of z, our continuous random variable, being less than c is 0.57. Find the value of c. Alright, I'm going to do this over here. I'm going to make some room. Find the value of c. Going to be cut off there. Alright, I'm going to draw a picture to make it a bit clear what we're doing. So we've been given our standard normal distribution, and we know that at c, the area under the curve is 0.57. How do we find c? Well, we put it straight into the Cas. So we want to find c. What we do is we go to menu. We pop down to, oh, it's doing that thing again. Bear with me, let's reload our Cas. Just loading. Yep, here we are. Loading, loading, loading. being very patient. All right, calculate. So we pop over to menu, go down to probability, find our distributions, and this time we want the inverse normal. So this is going backwards. So here it's saying, well, what's the area under the curve you want shaded in? Well, I want 57% of the area, or 0.57. So you give it the area, and it'll tell you the C value. There you are. So it's 0.176. 0.176. So we can say C equals 0.176. And this is for example 1, part A. So that's pretty close to the mean, right? So if the mean's here, the mean's 0, and one standard deviation is 1, it's just a bit to the right of the mean, which makes sense. C equals 0.176. All right, what about for B? This time, it wants, it's telling us the probability that Z is greater than C is 0.91. So it's giving us something else. It's saying, all right, here's your C. There's C. And this is the area I want. Now the thing with your CAS is it only tells you the area from negative infinity all the way up to here. So you're going to have to change the problem to figure this out, to find that C value. So what you need to do, if that's 0.91, you need to find this green area. So that green area is going to be 0.09, and that's the value you use to find C. So let's go back, let's grab our inv norm, and let's change it from 0.57 to 0.09, and we should get something about negative 2 point something, I reckon. Negative 1.341. There we are. So C equals, C equals negative 1.341. So that's about, so there's the mean, there's negative 1, so it's about, yeah, it's about there. Negative 1.341 is our C value. So you can see how we changed the problem. The area under here is 0.91, so the area under here must be 0.09, and that's how we find the C value there. So that's example 1 done. Let's have a look at example 2. We'll clear that out of the way. Okay, find the value of C across this interval if the probability of Z being across that interval is 0.9544. How do we do that? Draw a picture with these. Pictures really help. They're very visual problems, really. It's just playing around with areas. So we know that negative C might be somewhere here and C might be here. And we want to find the value of C that makes this area 0.9544. So how can we use our CAS to do this? Well, really our CAS will only tell us an area from negative infinity all the way up to some value. So maybe if we find the green area, we can get somewhere. Let's find the green area. So the green area is going to be 1 minus 0.9544, which equals 0.0566. So that's the green area. All right, we've got the green area. But our CAS can tell us up to here. So let's find that area. Let's find the red area. Well, the red area, because it's symmetrical, is going to be half that value. So let's half that value with our CAS. 0.0566 on 2 gives us 0.0283. Okay, now we're talking. We've got this area, which is 0.0283. Now we can use our inverse normal function to work this out. Now we can punch it straight in. So it's 0.0283, which gives us negative 1.906. C equals negative 1.906, which makes sense because 95% falls within 2 standard deviations, right? So that's going to be, one standard deviation is, there's 0. One standard deviation is negative 1. 2 standard deviations is negative 2. So it makes sense that it's going to be some value close to 2. So that's example 2. Let's take a look at example 3. Example 3, x is normally distributed with a mean of 10 and a standard deviation of 2. Calculate x1 correct to 3 decimal places if the probability that x is less than x1 equals 0.65. Okay, I'm not sure how to do this actually straight away, but the first thing I'm going to do is draw a picture. I'm going to draw a picture and I want the probability that x, so x1 is going to be about, there's our center line, so x1 is going to be somewhere here, and that area is 0.65. Now what am I finding? I'm wanting to find x1. I'm wanting to find x1. So you can see what's happening here. Well, I can't find x1 straight away, but I can find z1. I can find z1 using our standard normal distribution. Then we're going to have to convert it to x1. Let's do that. Let's use our CAS. Let's find z1. So we're going to use our inverse normal. So we're going to go 0.065. So we get 0.38532. So z1 equals 0.38532. That's all well and good. Now we want to convert it to an x value. So we know that z equals x minus mu on sigma, which implies that x equals z sigma plus mu. Doing our transposition there. So I know the z value, 0.38532. We know the sigma is 2, and we know the mean is 10. Let's use our CAS to calculate that. That's times 2 plus 10. There's our x value, 10.7706. So that's 10.771. So x1 equals 10.771. Let's check that makes sense. So the standard deviation is 2. So we want, yeah, that roughly makes sense. That seems about right. Okay, example 4. This is where it gets kind of tricky with example 4. This is about as tricky as it gets. X is normally distributed, so let's throw down everything we know. Let's put down all our information. So we know that x is normally distributed with a mean of 52.3 and a sigma we don't know. We don't know sigma. But we know the probability that x is less than 48 is 0.229. So we've got to get the standard deviation. So we don't know this. They're getting us to work backwards, which is kind of tricky. But whenever this happens, draw a picture. Sketch your normal distribution. Let's see. So what information do we have? We know the mean is 52.3, so 48 is slightly left of the mean. So that means that area, let's just clear that up a bit. It's left of the mean, so that area there is 0.229. and we know that x there, the x value, is 48. Well, we can find a z value there. We can find a standard value. Let's find z using our inverse normal function. So we'll grab our inverse normal. Let's find z, 229. So z's negative 0.742114. Was it 114 or 144? 144. Negative 742,144. Okay, so that's the z value. Okay, we've got a z value. We've got a mean. We've got an x value. Let's throw down our formula. Z equals mu minus sigma on, mu minus x on sigma. Jumping ahead. So we've got z. We've got mu. We've got x. That'll let us solve for sigma. So let's rearrange this to make sigma the subject, which is what we want to solve for. And I've got some more room over here. So sigma equals mu, which is 52.3, minus 48, which is our x value, over negative 0.742144. Get out your CAS. 52.3 minus 48 minus 48 divided by that sucker there. There we are. So what do we get? Negative 5.79402. Negative 5.79402. Is that right? Negative 5.79402. Okay, that's weird because I expect a sigma to be positive. So maybe we just need to take the magnitude. Perhaps it's let's see, to 2 decimal places. I suppose because you square it to get the variance and then square root it. So yeah, so it implies that sigma equals to 2 decimal places 5.79. Let me just check that in the book because I got this problem from the book. 5.79. What have I done wrong there? I've written my formula wrong. I feel like a bit of a goofball. Oh my. I've written the formula wrong. Let's start again. Memorize your formulas. X minus mu on sigma, which implies sigma is x minus mu on z. So then you take your x value, which is 48 minus 52.3 over your z value, which is the wrong z value. Go on, keep it together. So that's sigma, and that gives you a positive value, 5.79. There we are. Okay, that's your answer. Silly mistake, writ the formula the wrong way around. This is the formula. That's the one to know. So really, like all these questions, they're not, like you use symmetry like you do on a unit circle, and if you're going to use any formulas, there's just really two. They're not too crazy. There's this one, and there's the transposed version. And if you're confident with your algebra, then there's really not much difference between them. They're just transposed versions of each other. So those are your two formulas really, and you can see I wrote it incorrectly and I got a wrong answer. So make sure you memorize those formulas. So in the next video, we're going to move on to a new topic, which is finding areas under curves. And if you have been, thanks for watching.